Today in class, you were introduced to the concept of ratios, equivalent ratios, and proportions. For tonight's homework, you're going to explore these concepts more. And tonight's homework will be most effective if you've had a chance to try those problems yourself first, and then use the video to help you check your answers. So to start off, what is the scale factor from rectangle A to rectangle B? And so it's going to be really important, just like we talked about in class today, to make sure you're comparing corresponding sides. So for example, the small side to the other small side, the large side to the other large side. So when I'm looking for a scale factor, I'm not going from 6 to 4, I'm actually going from 12 to 4, because these are the corresponding sides. So from 12 to 4, I'm noticing that it's getting 3 times smaller. And so that tells me that the scale factor is 1/3. Now we're going to write some ratios. So we're going to compare the short side and the long side, for example. So I could say the ratio of 6 to 12, so the short side to the long side, is equivalent to the ratio of x to 4, short side to the long side. I could also flip this and compare the long side to the short side. So I could say 12 to 6 is equal to 4 to x. I could flip both of them. But notice again, I've kept the corresponding sides together. So if I'm comparing 6, I'm also comparing it with x. It's either first or second, but I'm keeping those together. All right, so now what is the value of x? So if I set up a proportion, so I can set up 6 over 12 equals x over 4. That would match with the first ratio I wrote here. Or if I use the second set of ratios, I could say 12 over 6 equals 4 over x. Right? Those are the same thing, it's just written a little bit differently. So I'm going to apply my scale factor now. So 12 times 1/3, right, that was my scale factor from above, makes 4. So 6 times 1/3 equals x. And 6 times 1/3 is the same as 6 over 3, which is the same as 2. Again, I'm going to find the same thing over here. 12 times 1/3 makes 4. 6 times 1/3 makes 2. So I get the same answer either way. So then the last question here is to compare or write a ratio of the area of A to the area of B. So the area of A is going to be 6 times 12 makes 72. And the area of B is 4 times 2, since I now know that length, which is 8. So I'm going to write a ratio of 72 to 8. And I can simplify that ratio as well if I'd like to. So for example, I could divide by 8 and get 9 over 1. That would be fine to leave that as a ratio. You can also write ratios with words, 9 to 1, or with a colon symbol, 9 to 1 this way. So which pairs of rectangles are similar? Well, hopefully if you can set up some ratios to compare the side lengths, such as like the short side to the long side, you can find these pretty quickly. So in this case, for rectangle L, I'm going to compare 4 to 6, the short side to the long side, and I can simplify that to 2 over 3. For M, I can see that the shortest side is 2, so I have a ratio of 2 over 2, which is the same as 1 over 1. For N, my short side is 2, so I have a ratio of 2 over 3, and I'm going to notice pretty quickly that N with a ratio of 2 to 3 and L with a ratio of 2 over 3 are similar rectangles. So I'm going to note L and N over here. And then moving to the next rectangle, P, shortest side is 1, so I have a ratio of 1 to 7. For Q, a ratio of 3 to 3, which is 1 to 1. So I'm going to see here that Q and M, with their ratios of 1 to 1, are also similar. And then my last shape here, short side is 2, long side is 8. So 2 to 8 or 1 to 4. So P and R unfortunately are not similar to anything else. But now I'm going to go ahead and pull out the scale factor. So scale factor from the large rectangle to the small rectangle. So thinking about what I have here, L in this case is my larger rectangle, so 4 to 6. And N is my small rectangle, so 2 to 3. So now I'm going to look for a scale factor between these two rectangles, And so I'm going from large to small. So that tells me that my scale factor is less than 1. So I'm going to think 4 times what makes 2? And 6 times what makes 3? So you might think about doing 2 divided by 4 or 3 divided by 6 to find that number. And in this case, I'm going to find 1/2 is my scale factor. And so 4 times 1/2 makes 2, 6 times 1/2 makes 3. And then I'm also going to think about the other set of similar rectangles. So I have M and Q, and so Q is the larger shape, so 3 over 3. To the smaller shape, M, 2 over 2. And I'm looking for that scale factor. And this one is going to be times 2/3. Because if you think about it, I want to get a 2 from a 3, so I'm going to do 2 divided by 3 to find that scale factor. So 3 times 2/3 makes 2. Again, these are kind of tricky ones to think through. So my first scale factor was 1/2, my second here was 2/3. And now I'm going to go the other direction. This probably is a lot more comfortable for you. So now I'm going from 2/3 to 4/6, and also from 2 over 2 to 3 over 3. And so from 2 to 4, I can see I'm multiplying by 2. So just a scale factor of 2. And from 2 to 3, this is going to be a scale factor of 1.5, or 3/2. So you can write it as a fraction, or you can write it as a decimal. But those are the two scale factors you should have there. And now we're going to find the ratio of the area of the larger rectangle to the area of the smaller rectangle. So these areas, for example, for L, the larger shape, I have an area of 24, 2 times 6. So 24, 2. The smaller rectangle, 2 times 3, would be an area of 6. So 24 to 6. So you can leave it like this if you'd like, or you can simplify it down. So 24 over 6 can be simplified to 4 over 1. And then for the other set of similar rectangles, I've got an area of 3 times 3 is 9, 2 times 2 is 4, so 9 to 4. So 9 over 4 is fine to leave it as comparing these guys with their ratios.